Hi, everyone. Welcome to Transfer Learning with MLflow, a live interactive event collaboration between Fourth Brain and Databricks. Backed by Andrew Ng's AI Fund, Fourth Brain helps you take your ML career to the next level. Our cohort-based courses are designed to help you become the end-to-end ML practitioner that every company needs to win in the market today. Our unique approach to live in-classroom learning pairs industry standard tools with the big ideas behind them. We believe in building by doing, and so we've asked today's guest, as a resident expert at Databricks, to show us hands-on the #1 open source tool that you can learn today to reproduce and productionize your models. It's called MLflow. As always, before we meet our speaker, let's meet each other. Our small but mighty community is global and growing, and you never know what connections you might make at today's event. Let's share a little bit about ourselves in the chat and where we're tuning in from. As usual, I'm Greg Loughnane, the Director of Product and Curriculum at Fourth Brain, and I currently live in San Francisco, California. What about you? What do you do? And where are you tuning in from? Let's keep the intros coming in the chat as usual. We love to hear from you. No matter where you're tuning in from, you've probably heard of Databricks, the data lakehouse architecture and AI company founded in 2013 by the original creators of Apache Spark, Delta Lake, and MLflow. As one of the hottest startups in AI, they raised a whopping $2.6 billion in 2021 over consecutive funding rounds to fuel massive growth in recent quarters. Today's session will serve as a deep dive into one of the most popular open source ML tools on the internet and the most popular MLOps project, with 11 million downloads per month as of May 2022. Of course, we're talking about MLflow. Today, we'll help you see why it has become so incredibly popular. The code demoed, of course, will be shared with all of you as we get started with the session. A quick note on process. We'll hear from our speaker, who will present key technical concepts behind convolutional neural networks, transfer learning, and MLflow before each piece of today's demo. Following the demonstration, I'll ask a follow-up question or two, and then we'll open it up for Q&A from all of you. If you see anything that piques your interest as we go along, please drop your question directly in the YouTube live chat, and we'll get to it. With that, I'm excited to give a very warm welcome to Feifei Wang. Feifei is currently a senior data scientist at Databricks. She recently spent 5 years at Disney, where she was a senior decision scientist. Prior to joining Disney, she was doing research in robotics and received her PhD from Iowa State University. Feifei, take it away.
Hello, I'm here. Thank you so much, Greg, for the introduction. I feel really honored to be invited to give this talk today. Let me start sharing my screen. So today, I'm very excited to talk about a Databricks demo, Transfer Learning with MLflow, the #1 tool to learn today. My name's Feifei, and here's my email address, feifei.wang@databricks.com. Please feel free to reach out afterwards. I would like to begin with a very brief introduction about myself. As Greg mentioned, I did my PhD in applied mathematics and computer science from Iowa State University. Around the 3rd or 4th of my grad study, maybe the 3rd year, I started to watch some machine learning YouTube videos from Andrew Ng, and I was really inspired and feel that's a very fascinating field to go to. So I joined Disney right after my graduation and became one of the data scientists. We help Disney grow the business, making business decisions and building different machine learning models and analyzing the data. So as time goes on, we saw tons of big data come in, and we need some tools to help us build everything faster, query the data faster, and productionize everything all together. So we adapted a tool called Databricks. That's very fascinating. I immediately fell in love with this tool. So earlier this year, I actually landed a job as a senior data scientist at Databricks, and I have been enjoying my job so much. And today, the demo I'll be sharing with you actually was related to part of my interview. I was able to do a yoga pose classification problem using transfer learning, and that impressed one of our interviewers. So I hope you could learn something from our demo today. And instead of yoga poses, we actually will be seeing some very cute cats and dogs as our image classification use case. After work, I enjoy playing piano and taking ballet classes. I still actively perform at different locations. And here is our star. His name is Simba. He's an orange cat that I adopted from street. He's very smart. He likes learning as well. And later you'll be able to see his picture in our demo and also in our transfer learning algorithm explanation. Please feel free to drop in the chat and let me know, are you a cat person, are you a dog person, or you like both or neither? So let's have some quick introduction about Databricks as well, if you haven't heard about us. So Databricks is a unified data analytics platform. So we can use this as a collaborative space to do our work all together, regardless if you're a data engineer, data scientist, machine learning engineer, or data analytics. We can all come into one workspace and do our work all together and collaborate. Behind the scene, we have something called Delta Lake. So instead of just traditional Parquet files, we also add additional layers on top of it to ensure the data quality, consistency. We can do time travel for our data. We can ensure the schemas are consistent over time, and many, many functionalities. Databricks has also created something called MLflow, which is also one of our main focus today for our topic. MLflow helps with the reproducibility of our models and also the productionization process. We'll definitely learn more after today. Through today's talk. I hope you will definitely learn something. All right, so let's go to the outline. On the top, you can see I have prepared 2 notebooks for live demo. And before I doing any live demo, I will make sure to post a GitHub link so you could follow through and read through the code while I'm doing the demonstration. So below is actually all our slides content. We'll begin by a brief overview for convolutional neural network and the use case for transfer learning. Specifically, how can we build a model for image classification for cats versus dogs? And then we will begin our first live demo of notebook number 1, focusing on the transfer learning specifically. With only one line of code change, I can immediately call MLflow autologging, and that will give us a lot of great benefits of automatically logging the parameters, metrics, and so on. So we will go back to the slides, do the MLflow overview introduction, and then come back to notebook number 1 to track the autologging results. We would definitely like to have a deeper dive about MLflow. So instead of autologging, we can also specifically log certain tracking parameters and also use model registry. In this section, we'll do a deeper dive, and followed along, we have notebook number 2, specifically focusing on the MLflow components. We will then wrap up with additional topics of model serving, monitoring, Delta Lake feature store, and so on. And I will give you about 10 to 15 minutes at the end for Q&A. All right, let's get started for our convolutional neural network and transfer learning. So for convolutional neural network, it actually has a very broad applications. It can be used in image classification or even some NLP. So let's say you have some raw text, you can also classify your text into different authors. It can be used in face recognition as well. This picture gives you a high-level overview of a specific use case of vehicle image classification. So on the left, you have some input about like one of the image. It can be a car or bicycle. And in the output, it will tell you one of those classes that you're predicting for or classifying for. So in between, those are very important feature learning layers. So that include like convolutional layers, pooling layers, and so on. After this many different layers, you would usually flatten it out and also have a fully connected layer for your different neurons to connect together and apply the softmax functionality at the very end for the classification. So some of you may have recalled that for pooling layer, it helps you reduce the dimensionality, like max pooling, average pooling, those are very commonly used. And if you don't recall some of the detailed mathematical definition, I definitely strongly recommend you to look them up, like the pooling layer definition or what is a ReLU activation function. In the next couple of slides, I will focus more on the convolutional layers, which is basically the essence of our CNN neural network. So you can see that for our image, you can imagine those pixels, especially those neighboring pixels. Together, they have some spatial information that can be learned through CNN, and that can help us extract the specific features out. So let's see how that works. There is an image on the left. Let's imagine the blue image as an input, and the green kind of image is basically one mapping as the output as our feature map. So what it does here, you can see the 3x3 gray color grid that's moving along the original input. So what we are doing here is a matrix product of this gray colored 3x3 filter together with a submatrix from the blue image, which is also a 3x3 matrix. And we're doing a product together to map it into one value that's resulting into the green image. So in this way, we actually are utilizing those spatial information. And you can see on the very far right, there are different types of filters and that you can apply here and receive this feature map from a handwritten digit 9. Now let's have some more visualization about different layers of those kind of convolutional results. So at the lower layer, or usually at the beginning layers, you would usually see the feature map look like something like a lines or triangle, very, very simple shape, or even some of the colors. And you go a little bit deeper into your model from the middle level layers, you would see the feature more like some texture, almost feather looking or some grid looking things. And at the high level features, you would see something more specific to your training data set. It can be a specific type of fish. So you're starting to see even more fine details. So we have just talked about CNN. Then how does transfer learning relate to CNN, and why do we even use transfer learning? So one of the greatest benefit of using transfer learning is that even if you have a relatively small training data set, say just a couple hundreds of images, you could still build something amazingly accurate by utilizing the pre-learned model from a more complex setup. So in this graph, you can see that the definition of transfer learning can be summarized into storing the knowledge gained, solving one problem, and applying it to a different but related problem. So in our specific use case today, we can think about like this. On the left side, we actually have the more complex model that's built off from ImageNet. This is a very popular data set, consists about more than 2.5 million different images from more than 1,000 different classes. It can be jellyfish or some object, some vehicle or airplane, and some sort of animals. So it's like a diverse type of data set that you can use. And many, many machine learning scientists have already trained on this ImageNet for hours, for days, that they built something very fancy and many, many deep layers to help with this classification problem. So today specifically, I'm introducing the MobileNet V2 that we will be using. And with this knowledge from MobileNet V2, all we need to do is modify the last layers related to the classification and using our cats versus dogs images and cats images, dogs images, and then retrain those last layers to immediately get a very well performed model already, just within seconds or minutes. So you can imagine that with transfer learning, you can easily adapt your use case by utilizing or transferring the knowledge from an existing, more complex model. This is a brief recap of what we just talked about. On the top for the red picture, you can imagine that as our MobileNet V2 model with many deep layers and eventually doing the classification on those ImageNet categories. There can be 1,000 classes over here. And with transfer learning, we're maintaining those common feature layers at the front part of it, and then modify the last layers specifically into a binary classification of cats and dogs. And we are pushing our 2,000-3,000 images of cats and dogs into this new model, and then retrain the last layers to still achieve a high accuracy of classifying either cat or dog. So with this, I'm very excited to show you our live demo. And I would like to show you how you can download my code. And you may not be able to follow along since we have limited time, but I definitely encourage you to try it afterwards. So you can type in github.com/Feifei www, and you'll be able to come to my GitHub account. And there's this repo over here called the Transfer Learning with MLflow. And you can see I have notebooks and slides for you to download. So we'll just download the entire zip folder and then open it up in your local downloads. And yeah, so now you can see the notebooks here. I have 1 and 2. If you don't want to run anything, you can always just open an app, directly view those kind of code result I have pre-generated for you. So I will be running my demo today on Databricks. If you are not familiar with it, this is how the UI look like. So once you log into your enterprise account, you will see on the left, on the top, there are different personas. And today will be under this machine learning persona. And there are like workspaces is basically where you store your notebooks that you can run your code. We also have something called compute that you can create a specific cluster for. And today we're using the cluster I have pre-created that's under 10.4 LTS ML for the runtime version. So if you wanted to create something here and make sure you're selecting the 10.4 LTS ML. So I will skip this step because I have already created my own and it's running right now. So there's also the experiment tab that related to MLflow and also the models tab that we will touch on the functionality at the end of our demo today. So let's see how I can load the notebooks into my workspace. So this is how your workspace look like. It should have your username here. You can create different folders. So for me specifically, I can import it over here. So go into the notebooks. Let's say I'm just randomly trying to import one of them. And you can see there are different formats that's actually supported. So here I'm just importing this IPython notebook. Okay, give it a little bit of time and then click import. Yeah, and then immediately you'll be able to see the imported results. So for our demo today, I wanted to save some time, so I already pre-run my notebook. So I would like to share my notebook with you to view this result, specifically focusing on transfer learning first. So this notebook has been modified from the TensorFlow tutorial of transfer learning and fine-tuning. If you want even more details, please feel free to refer to this document as well for more detailed comments in between. But for us, we will begin by importing libraries. And this is the only MLflow comment in this MLflow code in this entire notebook. We will definitely come back later to it. So let's continue with focusing on the CNN code for now. And we'll begin by create our train validation test set. You can see there are 2,000 training files belong to cats and dogs images, and we're splitting this into additional 80-20% of validation and testing set. we'll begin by display some example images from our training dataset. You can see some cute cats and dogs. Some are profile pictures, some are sideways, whole body, so all different types. And there is an important step here called augment data. It's optional, but it actually gives you some kind of free labeling in some sense. So what we are doing is, instead of just using the original vertical taken picture, we are actually adding some random rotation about 20% range, like left or right, about 20% to rotate this picture. So it gives more a variety to our training data set. And this will help our model to learn better, because it's possible that somebody will take a picture in a tilted way. So after this augmenting step, we're actually loading our base ImageNet model, the MobileNet V2. So remember, this is what we talked about. This is the complex model pre-trained. So with several steps, we just load it in. Notice here, I have said include top equals false, which means the last layers, we are not including it, because later we want to add our own layer for specific cats versus dogs classification. So this is our base model summary. You can see there are input, there are different convolutional layers, pooling layers in between. It's many, many layers until going to the final output. You can see here, this model already has 2.2 million parameters after removing the top layer. So it's already a very, very fancy model. We are actually not retraining it, but what we are going to do using transfer learning is to simply doing some pre-steps of augmenting and processing and adding a global average pooling layer and adding this dropout layer to prevent from overfitting and adding the prediction layer. So now we can just compile our model together in just such a simple step. So now this is how our model look like. The base model MobileNet V2 is over here. You can notice that it's non-trainable for those MobileNet V2, the 2.2 million parameters. And we're only adding our last layers to retrain those parameters to help us recognize cats versus dogs. And those are only about 1,200 parameters. So let's begin training our model. To save some time, I'm only using 5 epochs. This is another tuning parameter you can change later when you play along. So we'll check the accuracy graph. You can see after only 5 epochs, the validation accuracy is already 92%, which is pretty good. So let's just quickly check some test set predictions. So those are 9 pictures that were not included in our training data set. So you can see it's predicting pretty well. Cats, dogs over here. If you want to look at one batch result, we have set the batch parameter to be 32. So you can see most of them, the labels matching with the prediction well, except maybe 1 or 2 here or there. So now it comes to our star, Simba today. What if I want to use this model on my own image? Unfortunately, using Databricks is very simple to load in my image. So all I did was upload my image under this data tab under Databricks file system. I created a folder and I uploaded several pictures. And just by a few lines of code, I can load in my image and see Simba's face over here. Let's see how the model is doing in predicting it, and while calling the sigmoid as the binary classification at the end. It does a pretty good job. It says it's a cat. So Simba should be happy at this moment. Now let's look at my friend's dog. His name is Dodo. Let's see, how does this model do on here? Oh, unfortunately, it's predicting it as cat. So this is probably some homework for our viewers later. You can definitely read a little bit more details about fine-tuning, which is also unfreeze several layers from our base model to make sure there are more features specifically learned for cats and dogs. You can definitely tune a lot of the parameters from your notebook to make your model even better. So now, after this first demo notebook, we have not talked about anything about MLflow yet. So let's dive into more details about what is MLflow. It is actually the most successful MLOps project today. So like Greg mentioned, it has 11 million downloads from May 2022, which is already beating PyTorch, following TensorFlow. So MLflow is actually an open source platform for the machine learning lifecycle. With just a pip install MLflow, you might be able to immediately use this tool. And what does MLflow do? It has those 4 major components. It can help you do tracking. So track your code, track your data, configuration results, and some model-related information as well. An ML project can help you packaging to different format to like help with the reproducibility of the runs on any platform. For MLflow models, it has a general format that standardized deployment path. And my MLflow model registry is a centralized and collaborative model lifecycle management. And today we will specifically touch on the MLflow tracking and also model registry. By now, you might still be confused by why do I even need MLflow? What does it actually do? So now I'm gonna pause 5 seconds and ask viewers to post in the chat. Do you remember from notebook demo number 1, what are the model parameters did we use? What is the learning rate? What's the beta 1 value? What's the number of epochs? I bet if you didn't write it down on a napkin or your notebook, you may not recall it exactly. So that's when MLflow comes in and plays an important role. So you no longer need to manually write down a lot of information during your model development phase. You no longer need to like have 1,000 Excel file open and just log all the detailed information. With this one line of code here, mlflow.tensorflow.autolog, you can see that I actually store those information automatically. There is an experiment tab that you can click this little arrow to open it up. So now let's go back to this link. So this is our MLflow UI. I can probably answer myself those questions immediately. So you can see, oh, here is the different beta values being logged. And this is our like learning rate and number of epochs and validation set accuracy, the 92% we saw previously. So in the background, MLflow already helps you autolog this information. If you rerun your notebook many times with different parameters, you will just see more and more rows coming in here. And you can analyze those results very easily by clicking compare or download into CSV file and programmatically even access it. So besides the parameters being logged, metrics being logged, the model information is also automatically being logged. Those are under the artifact tab. So you can see related to the requirement, count the YAML file, and even a model summary over here. It's very, very convenient. So now, after the notebook number 1, let's have a deeper dive about MLflow and see what exactly it can help us with our day-to-day job. So next, we will share some slides with you specifically to ML tracking and model registry. So I would like to sometimes specifically log some training parameters, metrics, and models that I'm interested in. And I would like to transition this model into different stages, like non-staging, production, or archive. So let's see some of the slides over here. As you may have already seen previously, there's a MLflow tracking server. So I can easily store the parameters, metrics, artifacts, including like model or even an image or some CSV files, metadata and model information on here. I can connect it through notebooks, some local apps like Jupyter Notebook, and also some cloud jobs. I can easily view the results through UI, API, or query it programmatically through Spark data frame. A separate topic is model registry from MLflow. So what is MLflow model registry? It actually is a central repository. you can create those unique named register model for discovery across the data teams. And the workflow is usually like provides specific UI and also API for the registry operations. On the model registry tab, later I will show you that you can also see different model versioning. You might sometimes change the model by just a little bit, like some parameter change. So you can see model version 1, 2, 3. So that allows multiple versions of model in different stages. You can push your model transition from none to staging to production or archived. It's also great with CI/CD integration. It's easily specify a version and you can just load it in to do your unit test and do some additional inspection. It's great for model lineage, provides a model description lineage and also activities. This is a brief overview for the full machine learning lifecycle. So usually we'll begin by some data preparation, featureization, and then the data scientists will come in to develop different models. And here you can see MLflow is greatly helping starting from the model development phase. We can help log those parameters, metrics, metadata in a programmatic way, and we can push the model to different stages from your dev to staging to production. And eventually it will help with the deployment and model serving as well. So with this much being said, let's jump into our second notebook demo, specifically focusing on MLflow. Again, I'm using the same exact example for transfer learning for cats versus dogs. But here, I'm also adding additional parameter tuning steps for grid search. And I wanted to see how MLflow is helping me in my model tuning process and the logging. And after that, I would like to also select my best model and register it into our model registry and push it into different stages. So now let's go to our demo number 2. So I have already opened it up in this second tab over here. I was running it earlier today. It took me about like several minutes to run this. It depends on your specific cluster and environment setup, but it shouldn't be taking too much longer. So let's go over the code really quick. It's the same step. We are importing libraries, creating the training test. So yeah, you probably already seen this code from notebook number 1. And starting from command number 12, we're doing something a little bit different. So we're adding this grid search here. So let's say I may want to find out what will be a better learning rate or beta 1 value when I build my model. So here I'm doing a simple grid search for 2 choices of learning rate and 2 choices of beta 1 value. And I'm having those 2 for loops here. And for anything, I would like to highlight this MLflow. So these are the commands that I'm actually using MLflow here. So I'm having a parent run here as the outer loop, and then have those child loop to log the specific inner loop run. So here you can see we're still building the models following the several steps. And at the end, I would specifically like to log this model we created and log the parameter of the actual learning rate and beta 1 value that I'm using in this inner loop. And I would like to log the metric of the validation accuracy as one of our comparison metrics. And I would also like to log an artifact of the figure. So after running this, I would like to come to my experiment tab and view the results. So I actually ran this about several hours ago. Like you can see here, there's a parent run. And if you click open, we see the 4 child runs over here. Those are the specific parameter we are logging here, like the beta 1 value and the learning rate. And there's also this validation set accuracy. So you can immediately see, oh, the third model seems to be the best. You can always do some manual comparison coming to the scatter plot. You can choose, say, like learning rate as my x-axis. So from this quick plot, you can see, oh, this bigger learning rate seems to achieving a higher validation set accuracy. So you may see the third model has a little bit different symbol. This is actually the registered best model, because when you are sorting by this validation accuracy, you can immediately see that this one has the best one that we want to use later. So now let's come back to our notebook and continue the journey to see how we can retrieve this best model run and register it under model registry. There are multiple ways we can do it. In this code, we are calling this MLflow client and pulling the information from our experiment run into like a data form, like a data frame format. So we can see there are different columns, and specifically over here, the metrics are being logged. And all we need to do is order it by the validation accuracy, and we can immediately retrieve the best runs ID. And now I want to move on to my model registry. So note that this functionality currently may not be available on the free Databricks community edition, but is available on my enterprise edition. So all we need to do is create this model URI, which tied to my best models run ID. And with one line of code, we can register this model, give it a name called demo transfer learning. And after we register the model, you can always access the model from even a different notebook by calling the command below, load model, and immediately apply to one of the images. So in this case, it's predicted correctly as the dog. So you can see here, we are using this loaded model from our model registry. So how do we visualize the UI part of the model registry? There are multiple ways. You could always go back to your experiment tab, click on this specifically logged models to view it, or you can always come here to the model tab and sort by the date last modified and owned by me. So you can see here, the demo transfer learning. This is the same tab that we wanted to see. And over here, you can add more description tags. You can click into the model version and see what is the source run coming from. And different stages, you can transfer it to staging production. And in the future, you can even try to do some model inference, batch inference, real time, and so on from over here. It seems to be very convenient. And with this centralized model registry, your coworker can also check the existing model and maybe save some time from rebuilding the same thing. Okay, so I hope you have learned something about MLflow, and I know I have done my demo under Databricks environment, but if some of you might be interested to use MLflow locally, I did not provide you the specific code, but here is just a brief overview that you will be beginning by doing a pip install MLflow, and you will call the UI after you run your model, and you can immediately open this link to view something very similar to what you can see for the MLflow UI under Databricks. So this is like how you can run it locally. And I encourage you to try it out with this transfer learning on your own computer and running it locally on Jupyter Notebook. Let's come back to our slides. So after the MLflow topic, actually Databricks also provide many amazing other functionalities. So let's dive into a little bit more about model serving, monitoring, Delta Lake, and so on. So actually the hardest part of machine learning isn't just ML. You can see the ML code is so small, it's tiny in the center, but everything surrounding it can also be some hidden technical debt. So Databricks is able to help it through different process. Like we have this tool MLflow to help with analysis, to help with managing and serving infrastructure. With the Databricks workspaces and different like functionality, we are also using Databricks to help with the configuration, managing the resources, even monitoring. We have the amazing Delta Lake, and that helps with the data verification, data collection. I have also attached some of the reference links for you at the end to view more information about our data lakehouse and so on. We also have feature store to help with the feature extraction and keep track of different features available. So like you see here, only a very small fraction of the real world machine learning system is the ML code. There are so many more things for us to continue explore and growing. So here are the references, including the CN transfer learning TensorFlow example, how you can try out Databricks immediately by signing up for a free community edition. And you can read more information about the state of art on image classification models and Databricks data lakehouse and my GitHub repo. I would like to especially thank my coworkers, James, Brooke, and Connor for their great feedback and slides preparation. So yeah, I'm happy to pause here, and please feel free to let me know if you have any questions. I will try my best to answer them.
Wow, thank you so much, Feifei. That was amazing. I really loved the breadth and the simplicity that you brought CNNs and transfer learning and MLflow to us with. And I can really tell that that our audience in the YouTube chat enjoyed it as well. Big thank you to Brooke, who is a colleague of Feifei's at Databricks, for helping to answer questions in the chat as well. I want to just kind of kick it off with one question that I had, because I'm really constantly focused over here at Fourth Brain on sort of end-to-end ML ops, and you mentioned sort of near the end of your presentation, you mentioned, and there's some model inference capabilities sort of built in here that we could keep going sort of down the pipeline if we wanted to, but that's beyond the scope of today. I'm wondering if you did all of this work developing these models, optimizing which data and model iteration you're going to use, registering each one, and you're like, okay, it's time to get this out of the notebook. What is the step that you would take to deploy this final model that you chose was the best to an endpoint? What would you do exactly? And would it include Databricks or MLflow or something else?
That's a very hard and great question. So from my past years, I was more focusing on the data science role. So a lot of time I would hand over my job directly to some other teams. So after I build the model, I say, hey, here's my notebook, productionize it and push it to some engineer team and make it productionized. But today, I'm still constantly learning, but with Databricks, we actually can help you simplify all those ML ops steps. So you will be able to even try it out yourself to help with this productionization and wrap it up into some format that can help with the deployment. And that will also simplify the engineer's work as well. This is an area that I'm also constantly learning, and I would hope maybe if you are interested in to reach out some of my coworkers, they can also show you some even amazing examples as well.
That's fantastic to hear. I mean, we're all always learning, and it's great to hear that even an expert like you continues to have things to learn at the edge of ML and of ML ops. I want to kind of double click in on this idea of what more there is that Databricks is offering. Offer Weintraub asks, hey, it's quite clear that the MLflow and transfer learning part, it's clear what's going on there, but not so sure what Databricks is adding to the game here. Can you expand a bit on when you would recommend actually using Databricks versus just MLflow and transfer learning?
That's a very awesome question. I would say Databricks is a unified platform, so it's great for collaboration and visibility. So you no longer need to say push the file locally, share with your collaborators. just under one workspace, everyone can see, oh, you have run this MLflow model, you have created this notebook, and those are the things available to share. And also behind the scene, we are using Spark framework. So imagine, like, I remember in the past time when I was running things locally, my computer always got stuck, especially if I'm having a Jupyter notebook open and having a live Zoom meeting call, then yeah, everything was stuck there because there's not enough memory. But with Databricks, we can query the big data immediately, very fastly using Spark. So that's something you may not be able to have it set up easily locally. And Databricks really help you save a lot of time just by doing that. And additionally, using Databricks product, it has a very short learning curve. You can see like the UI looks very familiar to you. It's notebook based for the workspace. And even within the same notebook, you can run both Python code and R code, even SQL code, Scala code, just at one place. And you can connect to like dashboard very easily. So you don't need to always output your data and load into Tableau or another platform. So like those all together are saving you time, and time is important for our development work. So you can push your project faster. So I would say like both collaboration, easy to use, and the big data, the Spark framework behind the scene, those are very critical points that I can see immediately.
And you mentioned it briefly there at the end, but for those of our viewers that aren't very familiar with Spark, could you sort of describe it in a sentence or two for everybody?
Yes, that's an awesome question. So I would say, let's imagine I have a lot of the chocolate and I want to compute how many yellow colored inside. So like traditionally, you may just open up every package, go through it one by one, like having a big for loop to add a counter. But with the Spark behind, with the parallel computing, you're actually able to make your jobs into subtasks, and each of the later, like the little computer can behind the scene and help you count the sub counts of the yellow, and then having like a main node, a master kind of to govern everything together and compute the total counts all together. So this is just a brief idea of like parallel computing. For Spark, it's also in memory process versus Hadoop. Hadoop has a lot of like write to disk, so it's a little bit slower. With Spark, with in-memory processing, it's so much faster. So you can do the count like just within seconds for like a very big file or very big use case.
So then the answer is something like, we can use MLflow open source, but we don't have this nice graphical user interface. We don't have this back-end parallel computing. We don't have any of the things that will just make our lives easier as a data scientist. And that's really what the unified system at Databricks is trying to bring to the table in addition to this open source project. Something like that?
Exactly. I totally agree with what you said. So everything has been already set up backend. You no longer need to make those connections on your own. You can just directly come into Databricks and running everything fluently. So that's really, really like, I love this product. That's why I feel since I have used it, it saved me so much of time. There are a lot of competitors on the market, but in my opinion, Databricks is definitely number one, because I have tried out other similar kind of UI, but from different company. They also have Spark supporting it, but the UI wasn't very user-friendly as much as Databricks and not as easy to use as Databricks.
Yeah, that's a great insight. You know, we're hearing a lot from folks that we interact with at Fourth Brain that transfer learning is sort of speeding up the project lifecycle. It's sort of allowing us to bring MVPs and quick endpoints into fruition very, very quickly. It's allowing us to speed up the process of machine learning development. How does Databricks think about, this idea of transfer learning models becoming bigger, and this idea of like democratizing the ability for everybody to leverage transfer learning as they become bigger and bigger? I feel like there's a connection between the stuff you showed on transfer learning And what you're mentioning about built-in big data capabilities in Databricks, I mean, is there anything that is sort of on the horizon related to, leveraging pre-trained models very, very easily within Databricks? How are you thinking about this new dynamic, this sort of Hugging Face-esque dynamic out in the marketplace, where we can take a model off the shelf and just use it, kind of like you did today, but with the giant transformers and things? Maybe you can comment a little bit on this. I'm very curious about it, and I know some of our students are as well.
Sure. I think you brought up a really great point, because there are other amazing companies that build something that we also want to maybe quickly adapt to it. So I think on Databricks, we also have like a partner connection that you can click on and immediately also import the tools or existing product from other company pre-built. So in that sense, Databricks is really great at collaborating and networking with different companies in the industry. So I would suggest people to check it out. We also have some excellent online blogs for people to check out called Accelerator. So there are some pre-built models for you to use immediately and very easily to run on Databricks. So one example I recently have used is a time series forecasting for some sort of sales data. So let's say very simple, like you have a data column and you have a sales column. So you wanted to do a forecast for the next year of the sales. And on Databricks, if you search the blog, you will be able to see like a blog specifically about the Facebook profit model that runs, say, like 9,000 models in parallel very quickly. Within minutes, you'll be able to see the result. So for this type of information, you can definitely find a lot of them online, and you can use them immediately in Databricks without changing too much. Another great part I would suggest people to try out is called AutoML. I did not have time to show the UI today, but basically you can upload your data into the Databricks database, and just a few clicks, it will help you, say, like build a regression model immediately. So you can see like there are different tree-based model and even traditional regression type of models that being tuned, and you can immediately select the best model and access that code in the notebook to start building your own model. So all those, I would say, can be very helpful to our students.
Yeah, excellent. There's so much technology just coming at all of us all of the time. And, part of the challenge is trying to figure out, what should we learn next? And, you mentioned data analysts, data scientists, machine learning engineers, and then we're even starting to hear rumblings of ML ops engineer job titles coming up onto the scene now. Can you talk a little bit about, first of all, what this looks like at Databricks? What the differences are in your colleagues between an analyst and a scientist and an engineer? And then can you also talk about, if I am an analyst or a scientist or an engineer, when should I be picking up these tools that you showed today, the MLflow style tool? When should I really start spending the time to make sure that I can do what we saw you do today, depending on my job title?
Yeah, definitely, Greg. So in my opinion, the job line definition in between data scientist, data analyst, data engineer, even ML engineer, ML ops engineer, like those definition of the lines are becoming more and more vague. Because nowadays, as everything developing so fast, we need to have more breadth of the knowledge of everything. So at Databricks, we do have different teams focusing on different things. Like we have engineers specifically working on those UI, developing new features. And I am at the machine learning practice team focusing on the data science work. But at the same time, like I also do some work related to ML engineer as well. So just data science knowledge may not be enough, because we will also be helping some of our customer clients to also deploy the models and go through the entire ML ops process. So in that sense, I would say sure, there are definitely focuses, like some are more software engineer focused, some are more science or statistic focused, but it's always good to learn more from different area. Yeah, so for the second question, like for our students who are watching today, I think since you are at the stage of observing all different information at the same time, pick out like maybe a focus of your favorite interest and then continue growing that one direction, but also branching it out. Like, let's say like I demoed MLflow today, you can definitely immediately start trying it by doing the pip install and try it out on your own and Google some docs, follow it along, and you will immediately get a better sense, because practice makes perfect. Like you have to practice, you have to get better with it. And at the same time, like constantly learning out more tutorials, joining different blogs and see different posts, doing more research on your own and figure out your own interests. So I hope those can be some helpful tips for our students as well.
And maybe for some new data scientists or analysts that you've worked with, how long has it taken them to pick up a tool like MLflow if they're new and they've never used it before?
Yeah, that's actually a very good question. I think it has a really short learning curve. With the MLflow, basically you go to this website, and on the MLflow website, there are very simple examples to show you here. Those are the key several lines of code that you need to add on to immediately start using MLflow. And also, as we have demoed today, if you don't want to manually logging some of the information just by one line of code, MLflow, the auto log, before you running your own model, like behind the scene is already auto logging some of the results. So you just need to get more familiar with the UI and you can start using it immediately instead of writing everything down on the paper for the parameters, or like manually creating Excel file sheets to even log things. Yeah.
All right, I've got one last audience question here. I think this is from a data scientist, probably. Let's think about the data scientists that are already working in a tool like Azure ML or like AWS SageMaker or Google's Vertex AI. And they're looking at Databricks and they're wondering, like, I have my workspace to train and test ML models. Why should I think about using Databricks or any Databricks tools if I feel like I have everything I need? Is there something I'm missing? Can you address this? I know you talked a little bit about user experience on the platform side. Is there anything else that you'd like to add for all the data scientists out there that sort of go into work and log into their home platform and never quite leave it to check out Databricks?
So that's bring a very great point, because a lot of companies, they may have their own preference. So maybe like everything is all AWS, everything is all Azure. But currently we are seeing our customers have been growing so much because more and more people realize how easy it is to use Databricks. As I mentioned previously, sure, there are other tools that might be similar, but like it's kind of accumulate over time, you will see, oh, it's actually easier to use Databricks for this functionality. So I would say different tool has their different advantages, but Databricks, to me, that can attract so many customers is because of the collaborative environment and the short learning curve for everybody to train on to use immediately. And we are still constantly developing new tools, new features to add onto our platform. So it's never stationary. We're always moving forward. We're adding more and more things to help with our customers for their entire machine learning life cycle. Yeah, definitely. So if somebody is stuck with Azure DevOps or AWS, I encourage you to maybe also begin by trying the community edition, but just keep in mind it's free, but it has very limited feature, but you can definitely have some sort of taste of it. And feel free to reach out to our Databricks specialists, so we can also try to help you with some free trials as well. Yeah.
Fantastic. Feifei Wang, everyone. This is a great time to take what she's shown us today, to try it out yourself on the Databricks Community Edition to add that tool to your resume and to make sure that you're at least experiment tracking like a pro with MLflow. So thank you all for your great questions. And thank you again so much, Feifei, for joining us. Thank you, Brooke, for supporting the chat. This brings us to the end of today's event. We hope that you've enjoyed your time with us and that you have a few actionable insights and lessons learned about how to leverage MLflow and Databricks for your next ML project, whether it involves transfer learning or not. Fourth Brain is grateful for the opportunity to showcase Databricks in this event and in our courses. Both our machine learning engineer program, our machine learning operations program, and many of our custom corporate training programs incorporate aspects of MLflow and Databricks that we got a glimpse of today. Trust us, this tool really is an amazing way to create value for many different types of companies, potentially even yours. Check out fourthbrain.ai for more information on upcoming MLE and MLOps course offerings to learn more. Our next 16-week MLE program launches August 9th, and our next 10-week MLOps program kicks off September 10th. That's it for today. We look forward to bringing you more interactive demo events delivered by experts soon, as we believe it's one of the best ways to teach and learn together. Give us a shout out if you have any ideas. And in the meantime, good luck as you continue your ML learning journey. See you again soon.